September 1943, London. The Blitz had been over for 2 years, but the city still bore its scars. In a cramped basement laboratory beneath Imperial College, Professor Reginald Whitmore hunched over a workbench covered in radio parts, vacuum tubes, and what appeared to be the remnants of a destroyed television set. His colleagues upstairs called him Mad Reggie behind his back. They had no idea he was about to build a weapon that would change the course of World War II. The problem seemed insurmountable. German U-boats were destroying Allied shipping faster than new vessels could be built. The Battle of the Atlantic was being lost, and with it, potentially, the entire war. British radar could detect submarines on the surface, but once they dove, the deadly hunters became invisible ghosts beneath the waves. Professor Whitmore had been dismissed from 3 different military research programs for proposing impossible solutions. His latest rejection letter sat crumpled in the corner. Acoustic detection underwater is theoretically interesting but practically worthless. The Royal Navy requires real solutions, not academic fantasies. But Reggie Whitmore had never been one to accept conventional wisdom. The Battle of the Atlantic was a nightmare. Every day, merchant ships carrying vital supplies to Britain were being torpedoed and sunk. Oil tankers, grain ships, ammunition vessels, all disappearing beneath the waves with their crews and cargo. The German U-boat fleet was strangling Britain's lifelines. Royal Navy escorts tried their best, but they were fighting an enemy they couldn't see. Once a submarine submerged, it became effectively invisible. Hydrophones could sometimes detect engine noise, but only at very short ranges and under perfect conditions. Most attacks came without warning, a torpedo striking from the darkness, followed by explosions, fire, and men dying in the freezing Atlantic. Whitmore had studied the problem for months. Military engineers had tried everything they could think of. They experimented with improved hydrophones, underwater microphones that could detect submarine engines. The results were disappointing. They tried magnetic detection, hoping to sense the steel hulls of submarines. It didn't work reliably. They even attempted visual detection methods, using aircraft and surface ships to spot periscopes. But submarines spent most of their time completely submerged. The fundamental problem was that the ocean was vast and submarines were small. Finding a submarine underwater was like looking for a needle in a 3-dimensional haystack, except the haystack was constantly moving and the needle was actively trying to hide. Every conventional approach had failed. Military experts had concluded that detecting submerged submarines at useful ranges was simply impossible with current technology. Professor Whitmore disagreed. The idea came to him during an air raid warning. As the sirens wailed across London, Whitmore noticed something peculiar. In his basement laboratory, he could hear the sound of footsteps on the floor above, even through the thick concrete. Sound traveled through solids better than through air. Why couldn't the same principle work underwater? That night, working by candlelight to avoid drawing attention, Whitmore began sketching what would later be called the first practical sonar system. But he didn't have military funding, cutting-edge equipment, or even proper laboratory space. He had spare radio parts, salvaged components from bombed buildings, and an unshakable belief that sound could hunt submarines. "You're wasting your time in Reggie," said Dr. Harold Pemberton, his department head, finding him working at 3 a.m. for the 4th consecutive night. "Sound doesn't work underwater. The Navy's tried everything." Whitmore looked up from his soldering iron, his eyes red with exhaustion. "They tried conventional approaches. Harold, sometimes you need to be a little mad to see what everyone else has missed." The mathematics were daunting. Sound waves underwater behaved differently than in air. They traveled faster, bent in unexpected ways, and were affected by water temperature, pressure, and salinity. Military engineers had calculated that any practical underwater detection system would require equipment too large and sensitive for shipboard use. Whitmore's solution was elegantly simple, He wouldn't try to make a perfect system. He'd build a crude but functional one. His death machine started with a microphone salvaged from a destroyed BBC radio studio. He attached it to a waterproof housing made from a discarded fire extinguisher. For the transmitter, he used vacuum tubes meant for radio repair, wired together in a configuration no textbook had ever described. The concept was revolutionary, yet simple. Send out sound pulses underwater. When they hit something solid, like a submarine hull, they would bounce back as echoes. By measuring the time it took for the echo to return, he could calculate distance. By analyzing the direction the echo came from, he could determine bearing. Working 18-hour days, Whitmore assembled his device from components that had never been intended to work together. The transmitter was built from radio parts. The receiver used a modified gramophone pickup. The display was nothing more than an oscilloscope he'd borrowed from the physics department. The entire system looked like something a child might build from a wireless radio kit. Colleagues who saw it shook their heads in disbelief. This cobbled-together contraption was supposed to detect submarines. It was madness. But Whitmore pressed on, driven by the knowledge that every day his device remained unfinished, more ships were being sunk, and more sailors were dying in the cold Atlantic. September 15th, 1943. HMS Trident, a British submarine, positioned itself in the Thames estuary for what the Navy had skeptically authorized as Professor Whitmore's underwater wireless experiment. On the deck of a small destroyer, Whitmore's strange device sat looking hopelessly out of place among the ship's proper military equipment. Naval officers gathered to watch what they expected would be an embarrassing failure. Captain James Morrison had only agreed to the test because Whitmore's department head had called in a personal favor. Private Tommy Chen from the Royal Navy's Technical Evaluation Unit arrived to assess Whitmore's contraption. He took one look at the cobbled-together device and barely suppressed a laugh. "Professor, this looks like a science fair project. The Navy needs serious equipment, not whatever this is." Whitmore patted his creation affectionately. "Appearance can be deceiving, young man. This science fair project can detect a submarine at a range of 2,000 yards. "Impossible," Chen replied flatly. "Our best hydrophones can barely manage 500 yards, and they're 10 times the size of your contraption." "But then perhaps it's time for a demonstration." Captain Morrison checked his watch. "All right, Professor, you have 30 minutes to prove your device works. The submarine is somewhere within a 5-mile radius. Find it." Whitmore switched on his apparatus. The makeshift display screen flickered to life, showing a horizontal line with occasional blips. For several minutes, nothing happened. Officers began exchanging knowing looks. This was exactly what they'd expected from the Tamad professor. The silence stretched uncomfortably. Some officers checked their watches. Others whispered among themselves. Whitmore adjusted various controls, sweat beading on his forehead despite the cool sea air. Then he made a fine adjustment to one of his vacuum tubes, and the display suddenly came alive with activity. "Contact," he announced calmly. "Submarine bearing 270 degrees. Range approximately 1,800 yards." Captain Morrison raised his binoculars and scanned the empty water in the indicated direction. "Professor, there's nothing there." "Just open ocean. Look beneath the surface, our Captain." Morrison signaled the ship's radio operator. "Trident, this is Morrison. What is your current position?" The radio crackled with static. Then came the reply that would change naval warfare forever. "Morrison, Trident here. We're at bearing 270 from your position. Range approximately 1,800 yards. Depth 60 feet. The silence on the destroyer's bridge was deafening. Whitmore's crude device had not only detected the submarine, it had pinpointed its location with remarkable accuracy. "How?" Captain Morrison asked, staring at the improvised equipment that had just accomplished the impossible. "Sound pulses," Whitmore explained, adjusting his controls as the submarine moved. "My transmitter sends out acoustic signals. When they hit something solid, Like a submarine hull, they bounce back. By measuring the time it takes for the echo to return, I can calculate distance. By analyzing the direction the echo comes from, I can determine bearing. And this works consistently. Watch. Whitmore made another adjustment. Your submarine is now turning to starboard and diving deeper. Morrison got back on the radio. Trident, report your actions. We've just begun a starboard turn and are diving to 90 feet. Captain Morrison stared at the primitive device that had just demonstrated capabilities beyond anything the Royal Navy possessed. The implications were staggering. If this crude apparatus could track submarines with such precision, what could a properly developed system accomplish? Within a week, Whitmore found himself in a meeting that would have been unthinkable just days earlier. Admiral Sir Percy Noble, Commander-in-Chief of Western Approaches Command, responsible for protecting Atlantic convoys from U-boat attacks, sat across from the professor who had been dismissed as a madman. "Professor Whitmore," the Admiral began, "your demonstration has caused quite a stir at the highest levels. The Prime Minister himself has been briefed. If this device works as reported, it could be exactly what we need to turn the tide against the U-boats." "It works, Admiral," Whitmore replied confidently. "But building enough units for the fleet will require resources I don't have. I need proper manufacturing facilities, trained technicians, and materials that are currently allocated to other programs." You'll have whatever you need," Noble said, without hesitation. "How many ships can you equip? And how quickly?" Whitmore did quick calculations in his head. "Now, with proper support, I could have 50 ships equipped with sonar systems within 3 months. Each unit costs a fraction of what conventional naval electronics cost, and they're far more effective. Make it 100 ships, the Admiral. And Professor, the code name for this project is ASDIC. As of today, you're working directly for the Admiralty. You have unlimited budget and priority access to any resources you require." The transformation was remarkable. Whitmore's basement laboratory was replaced with a proper facility in Portsmouth. His salvaged components were replaced with purpose-built electronics. His staff grew from just himself to a team of 50 engineers and technicians. But the core principle remained unchanged: sound waves that could hunt submarines beneath the waves. The mad professor had become the most important scientist in the Royal Navy, and his death machine was about to change the course of the war. October 23rd, 1940, HMS Starling was escorting a convoy bound for Gibraltar when her newly installed ASDIC system detected something that would make history. Lieutenant Commander Frederick Walker, the ship's captain, had been skeptical about the new equipment, but recent training had shown its remarkable capabilities. "ASDIC contact," reported Petty Officer Davies from the detection station, "bearing 350, range 2200 yards. Walker moved to the ASDIC display, watching the characteristic echo pattern that indicated a submerged submarine. For weeks, U-boats had been attacking convoys with near impunity, striking from beneath the waves and disappearing before escorts could respond. Not today. "All ahead, full," Walker ordered. "Prepare depth charges. We're going hunting." The German U-boat U-842 had been stalking the convoy for hours, waiting for the perfect moment to strike. Commander Klaus Weber had successfully attacked 12 Allied vessels using the same tactics: approach submerged, fire torpedoes, escape in the confusion. But as his submarine maneuvered for an attack position, Weber heard something that chilled him to the bone: the sound of a destroyer's engines growing louder. Heading directly toward his position with impossible accuracy. "How can they know where we are?" his navigation officer whispered, checking the periscope nervously. Weber didn't have an answer. German intelligence had reported no new Allied detection capabilities. U-boat command had assured him that once submerged, submarines remained invisible to surface ships. Yet somehow, this destroyer was tracking them as if U-842 were broadcasting its position. HMS Starling's ASDIC operator called out updates, Target bearing steady, range closing, 1,200 yards, 1,800. Walker watched the hunt unfold on his ASDIC display. The submarine was trying to evade, turning hard to port D, but the acoustic echoes followed every movement. It was like watching a predator corner its prey. "Fire depth charges," Walker commanded. The underwater explosions bracketed U-842 with devastating precision. Guided by ASDIC's real-time tracking, the submarine's hull cracked under the pressure. Water flooded the forward compartments. Emergency lights flickered as electrical systems failed. Commander Weber gave the order no U-boat captain ever wanted to give. "Emergency surface, abandon ship." U-842 broke the surface, her hull split and taking on water rapidly. As the German crew was pulled from the freezing Atlantic, Weber demanded to speak with the British captain. "How did you find us?" he asked Walker, his voice hollow with defeat. "Your ships have never been able to track submarines underwater before. What new weapon do you possess?" Walker smiled grimly, thinking of the professor who had built a submarine hunter from spare parts. "Let's just say we've had some help from a mad scientist and his death machine." By early 1944, ASDIC-equipped ships were systematically hunting down U-boats across the Atlantic. What had once been a submarine sanctuary became a hunting ground for Allied destroyers and corvettes. The psychological impact was devastating for the German Navy. German submarine losses soared to unprecedented levels. U-boat commanders who had previously attacked with confidence now found themselves hunted by ships that could track their every movement beneath the waves. The elite hunters of the German Navy had become the hunted. Admiral Karl Dönitz, commander of the German U-boat fleet, was baffled by the sudden change in Allied capabilities. In a desperate meeting with his staff, he demanded answers that no one could provide. "How are they finding our submarines?" he asked, his voice tight with frustration. "Our boats are being detected and destroyed at rates we've never seen. What new weapon do the British possess?" His intelligence chief, Captain Hans Rudolf Rösing, had only fragments of information. While captured submariners report that British ships seem to know exactly where our boats are located, even when submerged. They describe some kind of new detection equipment, but nothing matches any known technology in our files. "Find out what it is," Dönitz ordered. "Whatever the British have developed, we need to understand it and develop countermeasures immediately. We're losing the Battle of the Atlantic." But understanding ASDIC and countering it were different problems entirely. By the time German engineers began to grasp the principles of active sonar detection, Allied production had equipped hundreds of ships with Whitmore's invention. The statistics told the story of a war being transformed. In the 6 months before ASDIC deployment, U-boats were sinking Allied ships faster than they could be built. Convoy losses reached catastrophic levels. Britain was months away from starvation. In the 6 months after ASDIC deployment, the tables had turned completely. U-boat losses exceeded their replacement rate. Convoy routes that had been death traps became safe passages. German submarine crews, once confident in their technological superiority, now feared every patrol. The Battle of the Atlantic was turning decisively in favor of the Allies, and it was all because of a mad professor who had refused to accept that underwater detection was impossible. Back in his Portsmouth laboratory, Professor Whitmore continued refining his invention. The latest generation of ASDIC systems could detect submarines at ranges exceeding 3,000 yards. Multiple ships could coordinate their search patterns, creating underwater detection grids that no submarine could penetrate undetected. "Professor," said Commander Sarah Phillips, the Royal Navy liaison assigned to his project, "do you realize what you've accomplished? Intelligence estimates suggest your detection system has destroyed more U-boats than any other single-weapon system in the war." May 8, 1945, Victory in Europe Day. Professor Reginald Whitmore stood in his Portsmouth laboratory, surrounded by the latest generation of ASDIC equipment that had evolved far beyond his original cobbled-together device. The crude contraption he'd built from spare parts had become sophisticated systems that equipped naval vessels around the world. Captain Morrison, now promoted to admiral, found him there as victory celebrations echoed across the city. "Reggie," Morrison said, "do you understand what you've accomplished? Your detection system didn't just sink submarines, it secured the Atlantic lifeline that kept Britain alive. Historians are already saying you might have shortened the war by months, possibly years." Whitmore adjusted one of his latest devices, still tinkering after all these years. "I just solved a problem, James. The real heroes were the sailors who used these systems in combat, who risked their lives hunting submarines in terrible weather and dangerous waters." "Don't be modest," Morrison replied. "When everyone said underwater detection was impossible, you proved them wrong with radio parts and determination. You turned the hunters into the hunted. The Royal Navy owes you a debt that can never be repaid." The final statistics were staggering. ASDIC-equipped ships had detected and destroyed over 200 German U-boats. Convoy losses dropped from devastating to manageable levels. The Atlantic shipping lanes that kept Britain alive and supplied the invasion of Europe had been secured by a death machine built from salvaged components and audacious imagination. But perhaps the most profound impact was on the German submarine force itself. U-boat crews, who had once been the elite hunters of the ocean, became so demoralized that recruitment plummeted. Many experienced commanders requested transfers to other duties rather than face ships equipped with the mysterious detection devices that seemed to see through water itself. Whitmore looked around his laboratory, thinking about the journey from his basement workspace to this moment. "You know what the strangest part is, James? Everyone called me mad for believing sound could hunt submarines. But sometimes being a little mad is exactly what you need to see solutions that sane people miss." Years later, military historians would recognize Professor Whitmore's invention as one of the war's most decisive technologies. Sonar, the descendant of his crude ASDIC system, became standard equipment on every naval vessel in the world. Modern submarine detection systems, from advanced sonar arrays to underwater sensor networks, all trace their lineage back to a professor working in a basement with spare parts. But, perhaps more importantly, Whitmore's story became a reminder that breakthrough innovations often come from unexpected sources, not from well-funded programs or conventional thinking, but from individuals willing to challenge accepted limitations and build solutions that others deemed impossible. The mad professor, who assembled a submarine hunting device from radio parts and fire extinguisher housings, had proven that sometimes the most powerful weapons aren't built in factories or designed by committees. Sometimes they're created in basement laboratories by people crazy enough to believe that impossible problems might have simple solutions. In the end, Reginald Whitmore's greatest achievement wasn't just building a device that could detect submarines. It was demonstrating that innovation thrives when brilliant minds are given the freedom to be a little mad, to challenge conventional wisdom, and to build revolutionary solutions from nothing more than spare parts and absolute determination. The U-boats that had once terrorized the Atlantic learned too late that beneath the waves, sound had become their deadliest enemy. And it all started with a professor, a basement laboratory, and the revolutionary idea that Echo could hunt submarines just as effectively as any torpedo.